Hey, welcome everybody to session number 1 of 4 in our Switch Masterclass. My name is Kevin Wallace, and I am thrilled to have you with us. And I really want to give you a big thank you for entrusting me with about 10 hours of your time here in these live sessions, not to mention the extra couple of hours we're going to be spending in office hours. But hey, welcome everybody. And I'm noticing on the chat roll, this is how we're going to interact during class. A lot of people have signed in. They set up that free chat roll account so I can see them by name, like Chris and Jim and another Chris and Augustin. If you would sign into chat roll with your real name, that's going to make it a lot more interactive for us. And it's free. Just say if you don't have a chat roll account, just sign up for free. But that way I can call you by name instead of saying, "Hey, we've got a question from guest 2374." I think that'll be a lot more enjoyable for all of us if you'll go ahead and sign into chat roll. Now, before we get rolling with the actual content today, I want to just remind you about some of the different pieces and parts that make up this masterclass. And we call it a masterclass because it's comprehensive. It's everything you need in order to be successful on the Switch exam. That's exam 300-115. So let's take a look, just kind of a review of some of the different resources that you have out there. First of all, you've got the 10 hours of live training. Remember, we're meeting today and tomorrow, so Monday, Tuesday. Next week, we're going to meet Monday, Tuesday again. And we're going to spend 2.5 hours together in each of those 4 sessions for a grand total of 10 hours. You do have me as a double CCA as your instructor. I'll take you out in just a moment to show you how to get your hands on some live gear or simulated gear or emulated gear, however you want to do it. But we've got a practice exam for you as well. We talked about office hours. That's on Thursday. Thursday at 2 p.m. We're going to be meeting for about an hour, and we're going to be taking questions about anything that's tripped you up this week. If we've talked about a topic and you need to review it, you're not quite sure, that's what Thursday's all about. We can break things down and expand on those things on Thursday. And you're going to get replays of these sessions. So if you happen to miss a session, no big deal. You're going to be able to rewatch it. It will be posted later today. So sometime later this evening, you'll get posted in your members area under the session 1. Right now it says session 1 coming April 29th. Well, later this evening, it's gonna show up there. You'll be able to replay this session that you're watching right now. Also in that session 1 area, there's going to be the slides from today's session. So you'll be able to print those out, or it's going to be in a PDF format if you want to keep it like that. And please, please, please explore the Switch Masterclass Tribe. That's a discussion area. It's not like a Facebook group. It's a discussion area just for members of this class, where you can help each other, give advice to one another, ask questions if something's tripping you up. When I did this early in the month with the Route Switch, CCNA Route Switch Masterclass, it was so inspiring to see all the participants helping one another. After all, you're in sort of an elite group right now, if you think about it. I mean, everybody in here has paid $297 to be here. They're not just trying to find some free white papers and YouTube videos. They are committed, and you are as well. So that's a great group of people to hang out with, and just surround yourself with those people and use the collective IQ of the group in that chat interface. Now, I want to make sure that everybody's hearing me nice and clear. So can you just give me some feedback in the chat roll? Say, "Yep, we're hearing you." So, or 5x5 or whatever it is they say, that if I'm coming through loud and clear, just want to double check the audio. Oh, and there's a bonus, and I decided to just give it to everybody, is the fundamentals of network programmability. So everybody's going to be able to go through that. Let's see. Oh yeah, Chris vouching for the Tribe being great with the Route Switch Masterclass. Yeah, Chris joined us earlier this month for that masterclass. But because everything really is going to network programmability, we're throwing in that course for free. But let me give you just a quick tour. When you go into your account and you go into you click on My Library and you log in, the way you got here today, obviously, was you went into Switch Masterclass Live. Let's go into View Product, and you went into Live Room. Well, like I said, this evening, you're going to go into Session 1 And in session 1, you're going to be able to download a PDF of the slides, and you'll be able to download, if you want, a replay of today's session. Also, at the bottom here, we've got the home lab manual. You see, there's a couple of ways you can do labs in this course. Some people want to buy their own gear, and you could probably do it for less than $200 on eBay. And if you download this PDF document, it recommends the 3 switches that I recommend. I tell you what cables to get, and you can set up a home lab probably for less than $200. And if you want to do that, this is an 80+ page PDF that walks you through, I think it's about 24 different labs. And I'm going to be assigning some labs from this as your homework at the end of each session. But that's just one way that you can get hands-on experience. Another way, I know we've got a lot of viral users, so we threw in our Cisco Viral Labs product. Now here, if you go into the Viral Labs product, it's not just switch. We also threw in, we thought, why not? We gave you the route labs as well, but you're going to go in here like one of your homework sessions today. If you're a viral user, is going to be on RSpan, and you're going to be able to watch a video, and we'll say, hey, here's what you're going to be doing in this lab. Then you're going to download this viral file over here in the downloads area. You're going to import it into your version, into your copy of Viral. You're going to do it on your own. And when you're done, you can come back and you can watch the rest of the video for a complete video walkthrough solution. So that's going to be the homework. That's going to be the lab exercises. In addition to that, we talked about the Masterclass Tribe. Here's where you would go, and you can just post something right here. Or if you want to be very topic specific, we've got different areas where you can ask questions about the different topics on the switch exam. What else do we have? Let's back out here. And when you get done with everything, you might want to investigate the switch practice exam. The switch practice exam is available in a couple of formats as well. What you can do is download the PDF. Now, the PDF not only contains a section with the questions, and after that, there's a section with the questions again, but this time you get the answers and very detailed explanations about why the answer is the answer. If you want to take it in more of an exam simulated format, it's available here. Just click on Start, and you're going to go through this 75 question online exam. This online exam engine will grade you at the end. It's going to help you measure your readiness for this class, or for the exam rather, for the 300-115 exam. Now, as we're getting started, I'd love to know your background. How far are you in your studies? If I'm assuming that most of you are going after your CCNP in routing and switching. So can you just chat into me just to get to know one another a bit better? Tell me where you are now. Have you taken the route exam? Have you passed the route exam? Or is switch your first exam? Maybe you've not passed your CCNA route switch yet, but hey, this was being offered, so you jumped on it while it was being offered. Just give me a 1 or 2 sentence summary, if you would, of exactly where you are in your studies. And while you're typing that in, I'll give you just a brief overview of my background, since we are going to be spending so much time together. Again, my name's Kevin Wallace, and I've got a couple of CCIEs, one in routing and switching, one in collaboration. I got my first CCIE way back in the year 2001. I got my second in 2012. I waited quite a while before I did another one. Took that long to recuperate from the first one. I've been working with Cisco gear for 30 years. I worked with the very first model of Cisco router, the old Cisco AGS Plus router. And I just love Cisco technologies. I taught for a Cisco Learning Partner for about several Cisco Learning Partners over the period of about 14 years. Real world, I was a network design specialist. In fact, I was one of 5 network designers down at Walt Disney World in Florida. I designed the network that tied together the Magic Kingdom and Epcot and the studios and the Animal Kingdom and several of the resorts. And yeah, that was an amazing place to work. They were an all Cisco shop. And I may be throwing in some Disney stories as we go through our switch class together. I've written a bunch of books, done a lot of videos for Cisco Press and Pearson. For the last 2 years, I've been a speaker, and I was honored to become I was awarded Distinguished Speaker Awards at the last 2 years of Cisco Live in the U.S. Bottom line is, I love this stuff. I'm not just doing this because, hey, what can I teach this week? No, I am passionate about this stuff. In fact, the main job I had at Disney was working with switches, with multi-layer switches. So this is something that I am very, very familiar with, and I cannot wait to share. Let's see what some of your background is. Let's see. Arnold's saying, just restarting my NP, never took an exam. And Todd says, oh, CCNP has expired. I'm going to go back and retake those. Jim says, CCNA route switch certified in April. Congratulations. Jumped right into switch training with your suggestion from the free webinars last week. Awesome. It's great to have you with us, Jim. Let's see. Danny's saying CCNA, DA, heading for NP, switch being the first one. I love it. Augustin says, I had CCNA expired, need to review, and then go to CCNP. Yeah, if you've got an expired CCNA, this will obviously tell you everything you need to know about the switch portion of that NE exam. David said, starting from CCNP route switch, been a voice collab for a number of years. Oh, me too. Love collaboration. Saw this offered and doing a lot of 9300 installs right now. Wow, that would be a fun. I haven't laid hands on one of those yet, but heard a lot about them. That'd be really cool. Let's see. James says, I've achieved CCNA route switch, CCNA security, CCNA CyberOps. Wow. Working towards CCP route switch. Well, James, you've proven your ability to learn a wide variety of technical content. I'm sure that you can get your NP as well. Let's see, Hitton or Heighton, pardon me if I'm mispronouncing that. Got CCNA, CCNA CyberOps, CCNP is expired. Hoping to do it the long way. In fact, I'm very interested in NP route, although self-study and Cisco through the self-study and Cisco scholarships program. And Hitton again says, also I'm a DA and a DP. Oh, me too. Unless they've expired. I got those a long time ago, and I don't try to keep those updated really. Augustine said, will I be allowed to take CCNP exam with an expired CCNA? You can take the exam, it just won't count. I mean, you won't earn your NP if your NA is expired. It won't prevent you from taking the exam, but you cannot be granted your NP certification if you have an expired NA. So yeah, you're going to have to retake that. And great. Thanks for sharing that, everybody. And by the way, even though we're going to be not taking questions for a period of time now, I do have some Q&A breaks built in throughout today's session, so don't worry about that. But obviously, we don't have a moderator, and it would just knock us off track if every time you typed in a question, if I had to stop class and go answer your question. So please don't be upset if I appear to ignore your question for a while. I'm not. I'm just waiting for one of our Q&A breaks, and we're going to give you like a 10-minute break about midway through the class. I learned after going to Avengers Endgame over the weekend that ran over 3 hours, you need a break after that amount of time. And we're going to be going for 2.5 hours, but I got ready for it. No kidding. I didn't drink anything for 14 hours to go see Endgame. And wow, I'm glad I didn't. That was an awesome movie. But let's get into the content right now. And we're going to start off just by seeing what's expected of us, what's on the exam. And I've got good news for you. Of all the different exams that are going to that make up the NP track, we're going to be covering I don't want to say the simplest one, but the one with the fewest things to know on the exam blueprint. I gave you a shortcut link there. It's kwtrain.com/switch blueprint. And if you just do a side-by-side comparison of this one versus like route, no kidding, this route's about 4 times as long, maybe longer than that. But this is just a fraction of the topics you need to know for the route exam or the T-sheet exam. So I think if you're getting into NP, this is the lowest hurdle to overcome, and that's why I recommend taking it first. It's fine if you want to take a route, but yeah, this is going to be the lowest barrier to entry into the NP track. And most of it's going to be on layer 2 technologies, obviously. Here we're talking about VLANs and trunking and VTP and ether channel and spanning tree protocol and all that fun stuff. But there is a decent amount of focus on security. There's a lot of security features, storm control, all kinds of things like that we'll be getting into, and infrastructure services. You might think, what are we talking about here? Is that like, what is that? That's really only one thing. Well, it's 3 things under one category. When you see infrastructure services, we're talking about first hop redundancy protocols. By that, I mean HSRP, VRRP, GOBP. We'll cover and we'll demonstrate all of those. But let's get into it. What do you say? Let's get into the real meat of the course, and we're going to be taking a look at some of the features that we find on a Cisco Catalyst switch. How does Cisco Catalyst switches work? And we hear the term all the time, layer 2 switches versus multi-layer switches. Let's distinguish between a layer 2 versus some people call it layer 3, some people call it a multi-layer switch. Well, a layer 2 switch is going to make forwarding decisions based on MAC address information, based on destination MAC address information. They don't have the ability to run routing protocols, or I gave the 2960 as an example on screen. That actually does have a little bit of multi-layer. It's a really good layer 2 switch. It can do a little bit of stuff. Maybe I should have used the 2950 as an example, which is a pure layer 2 switch. But yeah, layer 2 switches are going to make forwarding decisions based on destination MAC address information, not based on destination network addresses. They're not running a routing protocol. However, a multi-layer switch or a layer 3 switch absolutely can. Here I'm showing you a picture of a Cisco Catalyst 3650. And there's also the 3560s and the 3750s. There's a bunch of them. But yeah, these can actually run routing protocols like OSPF or EIGRP. We can create static routes and do all that fun routing stuff. So let me ask you a question. What do you think, just chat it into the chat roll if you would, what do you think a difference or some differences are between a multi-layer switch and a router? I mean, they both do routing. They both make forwarding decisions based on layer 3 information. What's the big difference? Go ahead and chat in what you think some of the differences are, if you would. And by the way, I'll tell you right now, there's about a 17-second delay from the time I speak something to the time you hear it. So when I ask you to type something in, I'm not going to see it for a while. So I'm killing time right now to wait for you to type some of your responses in. I'll give you some of them. Oh, yeah, and Chris, thanks for the reminder, Chris. Yeah, when you are asking questions to me and not just chatting amongst yourselves, or just giving information, put some question marks in front of your question. So as I'm scrolling through the chat roll, as you can see, there's a lot on here. I'll be able to say, oh yeah, that's a question. It'll jump out at me and I'll be able to spot that. But Augustine says, there's no difference between a router and a multi-layer switch. Anybody else have a thought on that? They both do have that characteristic in common of making forwarding decisions based on layer 3 information, but there are differences. For example, I'll give you the most basic difference is there's no auxiliary port on a switch. There is on a router. I mean, that's kind of a silly difference, but that's a difference. Routers tend to have more interface types. I mean, usually on a Catalyst switch, it's Ethernet ports. You can have all kinds of ports on your routers, like serial ports, FDDI ports, channel interface cards. There's a bunch of stuff you can put in a router. So it's more well-rounded in terms of a router is in terms of interface types. And also, typically the feature set in router iOS is a bit more robust. Yeah, that's what Chris is saying. Processing power. Memory, because think about this. If I've got a router connected to the internet, maybe going out to a couple of different internet service providers, and I'm learning the full internet routing table, what is that today? It's pushing something like 180,000 routes. Your multi-layer switch cannot handle that. That's too much for your multi-layer switch to handle. It doesn't have that many entries in what we're going to be talking about later called the TCAM, but a router might if it has enough memory. And that's yet another difference. So I want you to understand there are differences. One of the differences used to be people would say that switches are faster. They've got these ASICs, these application-specific integrated circuits. They're CPU basically that's built in, and it's going to be able to make decisions at the marketing term is wire speed, where routers are slower. Well, that was true back in the 1990s, but now routers are really, really, really fast, and they're pretty much at where, as the mathematicians say, we're asymptotically approaching wire speed. So there's basically no difference in the throughput. But to get back to our discussion of layer 2 versus multi-layer, great responses, by the way. Yeah, Todd says routers have WAN connections. Yeah, love that one. Yeah, more routing options, James says. I agree with that as well. Yep, a lot more features. But switches, we said they're going to make decisions based on destination MAC addresses. What are MAC addresses? Well, those are the burned-in addresses that we've got inside of our network interface cards, like your PC, just about any device that can attach to the to an Ethernet connector or even a wireless device has a 48-bit MAC address. And of those 48 bits, the first half of that, the first 24 bits, is called the OUI, the Organizationally Unique Identifier, which is also called the vendor code. You can look at this and you can just do an internet search for MAC address vendor codes, and you'll get a big long laundry list of here is a code that indicates this manufacturer. So if you're doing a debug or you're doing a packet capture, if you're using something like Wireshark, well, actually, Wireshark is really intelligent. Wireshark knows a lot of those vendor codes. And when you're looking at packets captured inside of Wireshark, it'll tell you that this is from like a Cisco device or an HP device or an Apple device, because they're looking at that vendor code and they've got a table of which vendor code goes with what vendor. And then the last half of the 48-bit MAC address, it's the responsibility of the vendor to assign that themselves. And a layer 2 switch is going to make forwarding decisions based on MAC addresses, but in order to do that, it's got to learn which MAC addresses are available off of which ports. So let's consider just a super simple analogy here. I've got PC1, and we'll say its MAC address is all A's because MAC addresses are written in hexadecimal notation. And PC number 2, it's got a MAC address that's all B's. And right now, we just powered up the switch, and we don't have anything in our MAC address table right now. But eventually, yeah, PC might send a response or send a packet or frame over to PC2. When that frame comes in the switch on gigabit 1/0, the switch says, let me make a note of that. I just noticed that a frame coming from the all-A's MAC address came in on gigabit 1/0. So if somebody later on sends me a frame that's destined for the all-A's MAC address, I know where to send it. I'll just send it out of gigabit 1/0. And then when the return traffic comes back from PC2, it's going to see that as well. And it's going to say, oh, on gigabit 1/1, I received a frame that came from the all B's MAC address. Let me make a note of that. The all B's MAC address is available off of gigabit 1/1. And now when subsequent frames come in destined for either of those MAC addresses, the switch knows where to send those MAC addresses. Now, Cisco has really evolved their switching technology. That, just as a bit of a history lesson, they got into the switching business because they were mainly just a router company, or they used to call them brouters when I got started. They could be bridges or routers, so they were called brouters. But they got into the switching business in the mid-90s, really. They bought 3 companies. They bought Crescendo, which I think was the Cisco 5000, Catalyst 5000 series. They bought Grand Junction, which led to the Catalyst 1900 series. And they bought Calpana, which led to the 3000 series. All of those are pretty much end of life now, but just a little bit of a history lesson. Cisco got into the switching business by acquiring some companies, and they really evolved the technology. For example, there's something called a TCAM. Now, for your notes, and I want you to take a lot of notes in this class, for your notes, when I say that we're storing information in a MAC address table, this MAC address is off of this port, I said that lives in the MAC address table. Well, there's another term for the MAC address table. It's called the CAM table, which oddly is MAC spelled backwards. But CAM stands for, in your notes, Content Addressable Memory. Content Addressable Memory. We can use those terms synonymously, a CAM table versus a MAC address table. And that's going to store which MAC addresses live off of which ports. But these switches, even if it's a layer 2 switch, they probably have some pretty advanced capabilities. We can do access control lists, much like on a router. And each of the rules inside of an access control list is called an access control entry or an ACE, an ACE. Well, we could also do quality of service. That's one of my favorite topics. You might have caught the quality of service webinar that I did. I did it last Thursday, I think. By the way, I did 2 webinars last week. One was on routing between VLANs on a Cisco Catalyst switch. One was on quality of service on a Cisco Catalyst switch. I picked those 2 topics because it's important to know that if you're working with switches, but they're not on the exam blueprint. I thought they were kind of missing. So I just did some bonus training on those, and I've taken them off. They're no longer publicly available on YouTube, but you have access to them. In this masterclass, if you scroll all the way down to the bottom underneath all the sessions and underneath the home lab, I just added it this morning. You've got replays and downloadable replays at that of those 2 webinars I did last week. But back to the story. We can have quality service rules. We can have access control list rules. And can you imagine the burden on the processor? Here comes a frame in where we can where we say, all right, what's the destination MAC address? Okay, it's got to go at that port. Let's see if it has any access control entries. Let's process this one, this one, this one. Let's see if it has any quality service settings that we have to pay attention to. Let's go apply those. You see, we're doing all those things one at a time. If we do those serially, it could slow down the forwarding of that packet because we're having to look all this different stuff up. What we can do instead is use the TCAM. Now that stands for ternary content addressable memory. The ternary content addressable memory is going to store the security access control lists. It's going to store the quality of service access control list as well, any rules. And it can just very quickly, very efficiently decide whether or not a packet is going to be forwarded or not. Maybe it's blocked, or how it's going to be treated. We don't have to process these things serially. We can do one lookup. The reason it's called ternary is we won't get into the math. I've read a lot about it, and wow, that's some deep stuff. But basically, we're querying the TCAM to see what we're going to do with this frame. Are we going to forward it? Are we going to drop it? Where are we going to forward it? Any quality service stuff? We can do that with one lookup. And the way we query this ternary content addressable memory table is we use 3 bits. We can query it based on a binary 1 or a 0, or they add what's called a don't care bit, like a wild card, an X, an asterisk, or something like that. And based on the way all the matrix algebra works, which we don't need to know about, it can make very efficient lookups. Now, let's take it a step further. That was with the layer 2 switch. With the layer 3 switch, we are going to be able to make forwarding decisions based on layer 3 information. We're running routing protocols, we could, on a layer 3 switch. So what's that going to look like? Well, there's going to be another table that contains that routing information to say that this network is available off of this interface. So in addition to having our layer 2 CAM, and in addition to having our TCAM, which contains the ACLs, the security, the quality of service ACLs, we're also going to have what's called the FIB, the forwarding information base. Now, if you're familiar with the concept of CEF, Cisco Express Forwarding, which we can have on a router, it also has a FIB. It's doing the same job here. It's taking the routing information from the processor and putting it into this very fast lookup table where we can very quickly say, we're going to this network. All right, go that way. And by the way, as a side note, in some of the literature, you might hear all 3 of these combined referred to as the TCAM. So don't be thrown. Now, technically, the TCAM contains the security, access control list information, and it contains quality service information, but collectively, we also can refer to the FIB and the CAM and the TCAM. Sometimes the whole thing is referred to as the TCAM. So just be careful about that. I don't want you to be tripped up if you're reading something and say, hold on, there's routing information in the TCAM. Kevin just said that it just contained access control list and quality of service stuff. Now, sometimes the TCAM refers to the entire thing. Now, what we're going to do, well, actually, let me talk about where we're going to place switches in the enterprise network. And then I want to take some questions just to make sure we're all feeling good so far about just some of the architectural stuff going on here. Now, this is Cisco's classic model for network design. Within the campus, we've got what I call the wiring closet switches. They're in the wiring closet, every floor on a building. You've got wires coming back from the different offices on that floor into the wiring closet, and you've got switches in that wiring closet. And those are called access layer switches. And there's probably some riser cable that takes us from those wiring closets down to like the ground floor or some other floor in the building, where we aggregate all those wiring closet switches together. We do that with switches, typically multi-layer switches, called distribution layer switches, or a building distribution layer switch. Notice the redundant connections between the building distribution layer. I didn't draw it here, but sometimes each wiring closet switch will connect to more than one distribution layer switch for redundancy. And the different buildings in a campus that have their building distribution layer switches, to get the buildings all tied together, and this could be a corporate campus. I don't know, have you ever been to San Jose, Cisco's campus, their headquarters? It's massive. I don't know how many buildings they have, but it just goes on for, looks just like square mile after square mile of Cisco buildings. I cannot imagine how many switches they have on that campus. But it was about the same thing at Disney. We had thousands of Cisco Catalyst switches. We had about 600 or so routers, but we had thousands of Cisco Catalyst switches. And to tie the buildings together, they go back to the campus backbone. And that campus backbone is concerned with three things: speed, and speed. Just like in real estate, they say it's location, location, location. Well, the campus backbone is concerned with speed. That's the way that works. But all three of these layers now can be switches. We used to say that routers would go at the backbone and routers would go at the distribution layer, but now it's really feasible and probably cost effective to put switches there. Maybe layer 2 switches at the access layer, maybe multi-layer switches or layer 3 switches, if you prefer to call it that, at the other layers. Now, when we're going out to the internet and maybe we're peering with a BGP internet service provider out there, there's where you're going to use your routers. Or you could use your routers maybe to terminate some VPN connections coming in from remote sites, because they might have the horsepower to handle that. We don't want to burden our switches with that. Or if we need a more robust feature set, that's for a feature that's just not available on the switches. There are definitely places to use routers, but we're seeing switches more and more out there, and the costs are just dropping. I remember when long time ago, working at the university, we had a router. It was the Cisco 7. Let's see, it was the I think it was like a 7013 model router. It was a 7000 series, and it had 13 slots in it. And that thing was a beast. We could buy one module with 2 ports on it. You know what? A 2-port module, and they were fast Ethernet ports, 100 megabits per second. 200 meg ports cost $10,000. And that was with our educational discount. But now I can go out to a local electronics store and I can buy, maybe some switches have 10 gig ports in them these days. It's wild how inexpensive they're getting. But yeah, switches are showing up in lots and lots of places. Now I want to go out and do a demonstration of the MAC address table. Before I do that, though, I want to see if we have any questions. Remember, go ahead and preface your questions with question marks. And if you did ask me a question like 15 minutes ago, it's probably scrolled off the top of the screen. Go ahead and ask it again if you would, and we'll take some questions while you're doing that. I'm going to go over to our switches. Here's the topology you see on screen that we're going to be working with. And by the way, I don't want to block any of the topology or any of the commands or anything. Normally, when we go out to a live demo, I'll turn my video off. Also, it seems to help with bandwidth a little bit because we're not having to repaint as much of the screen. So students that are on a slower connection, I've seen it be of benefit to them. But any questions? Now's the time to do it. Let's see. Vladimir says, fib and TCAM, that is to separate tables, right? Yes. TCAM contains quality of service, ACEs, access control list ACEs. The FIB contains routing information. The CAM table contains port to MAC address mappings. But again, sometimes we refer to the whole thing, all three tables, we refer to the whole thing as the TCAM. And I emphasize that because we're going to be reallocating resources inside of the TCAM later today. And I don't want you to get confused and think, well, aren't we fooling with the FIB now, not the TCAM? Yeah, we can refer to the whole thing as the TCAM, but yes, technically those are different tables. Let's see, and if you could just give me some phonetic pronunciation, because I don't want to mispronounce your name, but the H-I-T-E-N, is that Highton or Hitton? Just give me a phonetic explanation of how to pronounce your name, and I'll try to do better with that. Are there ACLs for switches, also known as VACLs or... okay. Yeah, access control lists on switches. You can actually have access control lists to block things like MAC addresses or IP addresses with multi-layer switches, what we normally think of as access control lists. But you bring up something called a VACL, a VLAN access control list. We can set up we can set up rules for traffic traveling between VLANs. So yeah, those are different. Those are different things. VACLs, by the way, not on the exam, which I think is odd. But yeah, those are different things. Would you please go over the TCAM? I think we already did that, Augustine. But yeah, real quick, the TCAM, again, technically, it contains quality of service information and access control list information. And if we're trying to decide what to do with the packet, instead of having to look at those things one at a time, we can make one quick lookup using the 1, the 0, the don't care bit in this big matrix that's built. And we're going to be able to know what happens to the switch in terms of security, or what happens to the packet in terms of security, in terms of quality of service, in terms of the egress port with one lookup. Let's see, are ACLs for switches also? Oh, we already had that question. Is there an ARP table? There is an ARP cache. Yes, we haven't talked about that because we were talking about how switches make its forwarding decisions. But yeah, there is an ARP cache for sure. Great questions. I love it. Great. All right, I'm going to mute my camera. Well, not mute. I'm going to turn off my camera, but you'll still be able to hear me as we go through just a quick demonstration. We'll start easy here. But we're on switch 1 of this topology. By the way, it's a Cisco Catalyst 3750 series switch. And if I want to see what we have in our MAC address table, also known as the CAM table, then I can do a show MAC space address -table. By the way, if you haven't already discovered it, the window you're watching this in, there is, if you hover your mouse over the lower right-hand corner, you'll see that there is a way to make it full screen. That's especially helpful when I'm out here doing demos and we've got the little small type. I've increased the font size, but it'll be a lot easier for you to see if you maximize your screen. And you can tell your chat roll to pop out into a separate window. So yeah, when I'm doing training like this, I'm attending training like this. Yeah, I normally will I've got more than one monitor. I'll normally have chat roll on one monitor and the actual video presentation on another monitor. But yeah, I'd recommend maximizing the video, especially during the demonstrations. Now, here we see a list of MAC addresses and the ports to which they are associated with. Now, notice that most of these say CPU. What this means is these are used by the ASICs, the application-specific integrated circuits inside of our switches. So these are not ones that we are particularly concerned about. This is not something we're going to manipulate. This is just the inner workings of the switch. We're mainly concerned about the ones that were learned or ones that we statically configured. Like here we see that I've got this MAC address was dynamically learned, and it lives off of port Fast Ethernet 1/0/13. We've got other MAC addresses, and they all live off of this port. A lot of people imagine it that we just have one MAC address off of one port. However, in this case, I've got a switch connected off of this port. And I've got some end user devices connected off of that switch. I've got some IP phones. We're all in one layer 2 domain. So sure, I can see their MAC addresses, and I know to forward those down, in this case, down to switch 2. Now let's zoom in on a particular interface. Let's look at show MAC address table interface, fast Ethernet. You know what? Let me go to another switch for this. Let's see here. No, I'll just stay with this one. I'll say show MAC address table interface fast Ethernet 1/0/14. Let's see. There was nothing much there. Maybe I do need to go. Oh, I know what I was thinking earlier. I do have some IP phones connected off of this switch. So let's do a show MAC address table interface fast Ethernet 0/14. Yeah, that's what I wanted to show you. Notice it tells me that there is a MAC address. Well, I won't read it off, but it's been learned and it lives off of this port. So if you want to see exactly what MAC addresses live off of which ports, you can specify that. You can specify exactly the exact interface in which you're interested. Let's give you another show command. We can do a show MAC address table, and we could look at, let's pick one of these, aging time. This says how long a MAC address is going to live in the MAC address table if we've not heard from it for a while. We can adjust that. In fact, I'll show you how to adjust that here in just a bit. If I want to look at statically configured MAC addresses, we could do that. Yeah, in fact, let's mess with that aging time just for fun. Let's say show MAC address -table aging time. And let's see what the default is. It says the default is 300. The units of measure are in seconds, so that's 5 minutes. We learned that a MAC address lived off a port. If we don't hear a frame coming in from that MAC address in the next 5 minutes, it's going to disappear from our MAC address table. We could do a show ARP. Somebody was asking about this, which is going to tell us information about what MAC addresses are associated with IP addresses that we're trying to reach. There's no traffic passing through the switch right now, but somebody asked about it, so I wanted to show you that's how you see the ARP cache. You just do a show ARP. Now let's change the aging time. We'll go into global configuration mode, and I'll say MAC address -table aging time, and notice I can give it in seconds, or I can say 0 to turn it off. But let's say let's do an hour. I'll say 3,600 seconds. That's an hour if I did my math right. And now when I do a show MAC address table aging time, we see that the aging time is now 3,600 seconds or 1 hour. All right. I turn my camera back on. Let's see. Also, the ARP table and all. Oh, yeah. Just looking at the questions, make sure nothing new came in there. So pretty basic right there. We see that a switch is going to learn dynamically which MAC addresses live off of which ports, and we said that this information is stored in the CAM. In addition to that, we have the TCAM, which contains access control list entries. It contains quality of service entries. And we have the FIB, a multi-layer switch if we're doing routing. But, and this is important for what we're going to talk about shortly, we can refer to the whole thing as the TCAM. More on that coming up in just a few minutes. The next feature I want to show you, though, is how we can get information about attached devices. There's a couple of ways we can get information about directly attached layer 2 devices. We could use Cisco's proprietary Cisco Discovery Protocol, or the industry standard LLDP. That's the link layer discovery protocol. And here's one of the things that just blows my mind about this. I can be sitting on a switch and I can say show CDP neighbors, and it's going to tell me information about directly attached Cisco devices that are also running CDP, even if we haven't assigned the first IP address. This is not using IP for communication. This is all happening at layer 2. These are layer 2 technologies. How is that possible? Well, we're using multicast MAC addresses for both CDP and LLDP. You can see it on screen, the 01000C and the all Cs. That's what Cisco Discovery Protocol uses as its MAC address when it's, or that's what the destination MAC address is that it sends its information out to. But it's only directly attached neighbors. If I'm attached to a switch and that switch is attached to a router and I say, show me my neighbors, I'm just going to see the switch. I cannot see through my neighbors. I can only see my neighbors. It's directly attached devices. They cannot be any more than just directly attached. They cannot be 2, 3, 4 hops away, as an example. And this is super useful for troubleshooting or for even building your network, building a network topology if you're going into a customer's environment. Well, I should preface that by saying a small to medium-sized customer. True story. When I was at Disney, first week on the job, and they created an account for me on their AAA server, and because I was going to have access to all the backbone routers and a bunch of the switches, and I thought, well, be nice if I had a topology that I could refer to. So what I decided to do was, because I thought, I know about CDP. I'll just go to one of these devices, because I got to log into all of them. I'll go to one of these devices and say, show CDP neighbors. And I'll get a legal size piece of paper and I'll draw the router or the switch there. And then I'll draw the attached neighbors. Then I'll go to each of the neighbors and I'll do a show CDP neighbors again. And I'll draw in all their neighbors. And then I'll go to, that does not scale very well. Did I mention that they had thousands of switches and hundreds of routers? It became evident after about 20 minutes that this is not going to work. But it can work if you go into a small to medium-sized business. Maybe they've got 5 switches, maybe 2 routers, maybe 1 router. Yeah, this is a way that you can very quickly map out a topology by seeing what's directly attached. And it's not limited to just a router or a switch. There's lots of Cisco devices that run CDP, like Cisco IP phones, even some servers, like the Cisco Unified Communications Manager server can do this. Now, that's the Cisco proprietary approach. There is an industry standard way of doing this that's called LLDP, the Link Layer Discovery Protocol. If you want to put it in your notes, the actual standard for that is the IEEE 802.1ab standard. Very similar to the purpose and life of CDP. It's going to give us information about directly attached neighbors. It's going to have a different format for the MAC address. It's not just one MAC address that's being used. It's everybody has the same organizationally unique MAC address that we send out to. But yeah, the MAC addresses are going to look a little bit different, but it's basically doing the same thing. If I had to pick one, though, I would probably pick LLDP, because it's not Cisco proprietary for one thing. It's vendor interoperable. And we're able to do some pretty cool things with it. Like later today, we're going to talk about Power over Ethernet. Now, this is sort of a newer thing. Not all Power over Ethernet does this, but some of the newer implementations of Power over Ethernet, if we've got 2 devices that speak LLDP, what we can do is the switch can provide a little bit of power to the attached device, and it can just sort of ask it, hey, what do you need? How many watts you need? And the other attached device that speaks LLDP, it says, yeah, I could use about 15.4 watts. And it would say, okay, you're a class 1 device. That negotiation can happen with LLDP. I'll tell you the traditional way of doing it when we get to that topic, but bottom line is it's pretty cool stuff. Let's go ahead and demonstrate right now. I'll turn my camera off again. Let's go ahead and demonstrate CDP and LLDP. And I'm going to start off here. We'll just stay on switch 2. We're already sitting here. We're going to start off with Cisco Discovery Protocol. We want to see what neighbors we have that are directly attached. Let's do a show CDP neighbors command. And notice that I do have a connection to switch 1. You can see in my topology, that's off of Fast Ethernet 0/3. And I've got a couple of connections going over to switch SW3, and I see both of those. Now, I did not draw this in the topology, but I'll let you know that they're there. I've got a couple of Cisco IP phones. In fact, it says they're IP phones. In fact, notice this, it tells me the model number of these switches. I've got a 3750, I've got a 3560, a couple of 3560 connections there. It's going to the same 3560. And it tells me the capability of these attached devices. It says, oh yeah, this IP phone, the H says that it's a host. Okay, it's an end user device. Yeah, I'll agree with that. It says it's a phone. That's the P. I agree with that. The M says it's a 2-port MAC relay. Now, what that means is this phone has an additional Ethernet connector in the back of it where we can sort of daisy chain in a PC into the back of the phone. That way, in a cubicle, we've got one Ethernet connection, and we've already had a PC plugged in. Now somebody puts an IP phone on my desk. Where am I supposed to plug this thing in? Well, you plug the PC into the phone, you plug the phone into the wall, and you're good to go. So that's what it means by the 2-port MAC relay. And if I want to see detailed information about one of my neighbors, I can say detail. And for my Switch 1 neighbor, look at this. It's going to give me information about the specific Cisco iOS version that we're running. You might not want to do that. You might not want to be so free with your information, especially if you're connecting out to another company. I know when I used to work at a university and we were peering with a major internet service provider, they were down in Atlanta, and I was able to do a show CDP neighbors, and I could tell you what they were running. I could tell you their platform, I could tell you their Cisco iOS version, and I could have researched to see if there are any known vulnerabilities with that. That could have been a security hole. So you might want to suppress that. If you don't want to send CDP information out of a specific interface, here's how you stop it. Let's go into interface. I don't want to mess anything. Let's go to Fast Ethernet 0/4. I don't think we're connected to anything there. I could say no CDP enable. So that turns it off for that one port. Or if I just wanted to turn it off globally, we could do that. I could say no, in the global configuration mode, I could say no CDP run. Now I'm not going to press enter there, but I could turn it off globally. You might say, why would you ever want to do that? In a lab environment, I've done that actually. If sometimes I'll want to have some switches acting kind of like PCs, just to pretend they're PCs in a topology, so I can go to them and I can ping from them, I can telnet from them, things like that. A lot of times when I do that, I'll start getting some error messages about trunk native VLAN mismatches because I'm doing things very differently on those switches, and those messages are being created because of the CDP information being exchanged. So I just turn it off in a case like that. But usually that's the only time I would turn off CDP. Now, interestingly, on many of your Cisco Catalyst switches, LLDP is not even on. Look at this. If I do a show LLDP neighbors command, it says LLDP is not even enabled. Here's how you turn it on. In global configuration mode, we say LLDP run. And this is kind of cool. Remember, I said that we might not want to be transmitting our information to our neighbor, but maybe we want to receive information from our neighbor. You could do that with LLDP. Let's go back into interface Fast Ethernet 0/4, and I could say no LLDP transmit, so I'm not sending information about myself, but I'm still receiving at this point. If I don't want to receive either, I could say no LLDP receive, and that would do that for me. We could also selectively turn on or off different, what are called, for your notes, TLV information. A TLV is type length value information. In other words, when I look at my information via you can do it with CDP as well. LLDP is a little bit more robust. But when I'm looking at my information, maybe there's some information that I'm willing to send my neighbor, but there's some information I'm not willing to send my neighbor. Check this out. Let's just stay in. Let's go back up to global configuration mode. I'll say no LLDP, and I can say TLV select. And here, this is information that would by default be sent to my LLDP speaking neighbor. Maybe I don't want to send, I don't know, the management address. I don't want to send that. So I could just suppress the sending of just that while I still send everything else. Now that I've got it enabled, I guess I need to go enable it I don't know if it's enabled on a neighbor or not. Oh, I know. It's not enabled on the other switches, but check this out. If I do a show LLDP neighbors, it is enabled by default on my Cisco IP phones. So it tells me about, oh yeah, these phones are attached off of these ports. The capabilities, the code's a little bit different. The B says it's a bridge. That's because of that extra Ethernet port I was telling you about. And the T, it uses a T for telephone instead of P for phone, which is what CDP used. All right. What else can we talk about here? Yeah, let's do this. Let's go to switch SW1. Let's just turn it on everywhere. Let's go to switch SW1 and say LLDP run. That turns it on globally. Let's do the same thing on switch 3. I'll say LLDP run. Now let's return to switch SW2 and see if we can now see our switch neighbors. We'll do a show LLDP neighbors command, and it only sends out those messages every so often, so we need to wait for a few seconds. We should see our neighbors popping up momentarily. Could take 30 seconds. Okay, there's one that popped up. Switch SW1 is now visible. By the way, careful with the interfaces. Some people get tripped up on this. When it says local interface and port ID, for this neighbor of SW1, the local interface refers to me. I'm on switch 2. It refers to switch 2's port, Fast Ethernet 0/3. The port ID shows me the ingress port, the incoming port on that neighbor. I'm going into switch SW1 on Fast Ethernet 1/0/13. And now we've waited long enough and we see all of our neighbors. So that's a comparison between CDP and LLDP. Oh, by the way, if you want detail information, it supports the detail keyword as well. And one other thing for your notes. You might hear the term, talking about LLDP made me think of this. You might hear the term LLDP Med, which stands for multi or media endpoint discovery. That is sort of an extension of LLDP. Remember, I said that some devices will support LLDP for power over Ethernet. They can negotiate their class of powered device using LLDP. Well, in order to do that, you've got to use LLDP Med. That's an extension to what we've been talking about. Not something to know for the exam. I just wanted you to know about it. And while we're here in the live interface, let me tell you about how we can manipulate the TCAM resource allocation a little bit. Remember, to go back earlier today, we were saying, hey, what are some of the big differences between a multi-layer switch and a router? And we talked about a few of those. One of them was capacity, the number of routing entries we can have. But think about it. A multi-layer switch could have different roles in life. Maybe it's in a wiring closet where it needs to know about a bunch of MAC addresses and maybe a bunch of VLANs, but it really doesn't need to know about many routes. It doesn't need to have a very big routing table. Or maybe it's up at the distribution layer or the core layer. Maybe it does need to know about lots and lots of routes. Maybe it is going out to a remote office, so we need to do a lot of routing and have to have a fairly large routing table. Well, we need to allocate our resources differently because there's a resource that says how many VLANs we can have. There's a resource that says how many MAC addresses we can store. There's a resource that says how many IP routes we can store. That is the way your TCAM is structured. It's carved up into those different resource areas, and we can alter it on our switch to meet the needs of our switch. Now, for your notes, here's a term for you. It's called SDM. Switch Database Management. That's what we're going to be doing. SDM is Switch Database Management. That allows us to see how the resources are divvied up right now, and we can change it. Let me show you. Let's do a show SDM prefer command, and this is going to tell us, for example, that in our current configuration, we're running something called desktop default. Now, default means that we're trying to give a good balance between routing, VLAN, MAC address allocations, how many of those things we can store. We're trying to just be a very versatile switch that would work well in any of those environments. But maybe we want to change that. I mean, right now it says I can store 8,000 unicast routes. Well, that's cool, but it's not enough for the internet. Let's see, we can have 1,024 VLANs. It's probably going to be enough. Oh, remember we talked about routed interfaces in our webinar last Tuesday, I think it was. Remember we talked about routed interfaces? Well, I can only have 8 of those right now on my switch. So maybe I want to reallocate some of these options just depending on the role of the switch. Here's how I would do that. We're going to say SDM prefer. Let's give some context sensitive help. And let's just walk through these if you want to take some notes. First is access. We might want to use this on an access layer switch. We might need to know about a bunch of VLANs, but we're really not doing much, if any, routing. So let's take resources from routing and give them to VLANs. We could also use default, which is what we have by default. This gives us a nice mixture. It allows us to do some routing. It allows us to do have some connected routes. It allows us to have 1,024 VLANs, as we saw earlier. It's just kind of a nice balancing act. Now, I'm going to skip the next one for just a moment and come back to it, and I'll explain why in a moment. But we also have the option of routing. Now, this might be appropriate if we're at the distribution layer, we're at the core layer. We need to have a fairly large routing table. Or we might say VLAN. VLAN says that, yeah, we need to know about a bunch of VLANs, and these VLANs have lots and lots of MAC addresses. I need to be able to store like tens of thousands of MAC addresses in my TCAM. So that might be the option for VLAN. Let's go back to this for a second. Dual IPv4 and IPv6. You see, on a multi-layer switch, the implication is we can do routing, right? And the way you do that, you say IP routing to enable that. But interestingly, by default, even though you have a multi-layer switch, you're not allowed to enable, by default, IP version 6 routing. You can only route IP version 4 traffic. Or let me show you. If I do IP routing, that's going to turn it on for IP version 4. If I try to do IPv6 routing, I try to do IPv6 anything, it says, we don't know what you're talking about. We don't know about IPv6. Well, this template, this SDM template, will allow us to do IPv6 routing, which a lot of people are shocked by that. You cannot do it by default. You've got to adjust your SDM template if you want to route for IPv6 networks. So let's do it. Let's see how to set that up. We're going to give the command. Let me get back. Yeah, we'll just do it from global configuration mode. I'm going to say SDM prefer dual IPv4 and IPv6. And here's what I was wanting to come back to and talk about later. Even though I'm saying, yeah, give me both IPv4 and IPv6 support, it still lets me give preferential treatment to VLANs or MAC addresses or kind of a balance or routing entries. It still lets me say default or routing or VLAN. I'll just go with that balance. We'll do the balancing act again. I'll say default. Now, as soon as I enter that by itself does not make it take effect right away. I'll prove it to you. If I do a show SDM prefer, it says that the current SDM template is still desktop default. But if we look down at the bottom, it says on the next reload, we're going to go to the desktop default for IPv4 and IPv6. We will then be able to route IPv6 networks. And I want to prove it to us. I'm going to do a reload. And yes, I want to save what we just did. And it's going to take about 3 minutes and 40 seconds to be specific to reload. While it's reloading, let me share with you a caution that Cisco gives us. They say, don't do what we just did. Don't enable IPv6 routing unless you really need to, because it's going to consume some additional resources from your TCAM. Your TCAM is only so big. And I mean, if we're looking at our TCAM resources up here, we've got all these IPv4 resources. Well, if we now enable support for IPv6, we've got to take the piece of pie and chop it into a lot lot more slices. We've got to slice out some places where we can put these IPv6 routes and these IPv6 access control entries and these IPv6 quality of service things. So it's going to make the slice of the pie a little bit less for everyone, but you might need it. Now, while it's rebooting, let's go over to Switch SW1. Let's see if we really need it. We can check on how our resources are doing by doing a show platform TCAM utilization. And for example, let's take our directly connected routes. Directly connected routes. The maximum number of individual routes we can have is 6,272. Currently, we're only using 25. So we're not having any problems there. For the number of access control entries, security ACs, yeah, I can have 1,024. I've only got 37. So it doesn't look like I'm really pushing any of these. I wouldn't need to make a TCAM allocation change based on that. And they're all so low, it's probably safe to do what I just did on that other switch to enable IPv6 routing. Let's see if we've reloaded yet. No, we're still in the process of reloading. So while we're reloading, any questions on anything we've talked about up to this point? Any questions? Now would be an excellent time. And chat those in. Let's see, what feature, or will that feature change with the newer release of 15.x on the 37XX and then 16.x on the newer 9300s? Will that feature change? I haven't seen the roadmap on that. There's probably, if the Cisco iOS is out, there should be documentation on it. You might want to go check that out. But again, the main focus of this, there's some stuff that I know is newer than what we're talking about, and I'll frequently point that out. But I want to make sure that you know what you need to know for this exam. This exam has been out for a few years now, so I'm trying to really focus on what you need to know for the exam. But yeah, feel free to ask about newer stuff. I'm happy to talk about it. But that one, I simply haven't looked that one up. All right, looks like we're about booted back up. Any other questions? Let's see. Remember, please put question marks in front of your questions. It looks like I'm missing some because of that. Which iOS version should we use with this lab? You can really use any version of like a 12.2 or higher for studies for this lab. 15.x is fine as well. All right. Looks like we're almost booted back up. Go back into privilege mode. And let's do a show SDM prefer now. Look at this. Now it says we're doing IPv4 and IPv6 default, which makes me think that I can enable IPv6 unicast routing. I couldn't do that earlier. If I say, I remember earlier I did IPv6 question mark and it says, I don't know what you're talking about. Now it's got all these IPv6 commands available to us. I could do IPv6 unicast routing. That's how we enable IPv6 routing on these routers. Get my camera turned back on here. And let's get back to our slides for a moment. And we'll take a break here in just a few moments, by the way. But first, I want to talk about power over Ethernet. I was hinting at that. We discussed a little bit earlier. The idea is there's a lot of devices out there that need power, but you might need to put them in a place that's not really in close proximity with an AC outlet. Like I'm building a home right now. Hopefully I'll move in hopefully before this masterclass is over, I'll be moved into my new home. I don't know if I'll have time to get my studio changed over there or not. So the background might change before we finish this masterclass next week. I hope it does. But I've got a bunch of access points over there, and I've got video cameras for surveillance, for security, and they get their power directly over the Ethernet cable. We could do this with IP phones as well. The IP phones that we saw attached to the switch a moment ago, yeah, the reason that they were powered up is that they were receiving power from the Ethernet switch. That's a much more elegant way of doing power than having to go out and buy some sort of a power supply and plug it into the already overcrowded power strip underneath your desk. No, we can just get power directly over the Ethernet cable. And when you're reading about power over Ethernet, these are the terms you might hear. Well, Ethernet cable, you know what that is. But you might hear PSE and PD a lot. That's and a lot of the technical specs, those acronyms are used a lot. The PSE, power source equipment, in our context, that's the switch. That's providing the power. And the device that's receiving the power is the PD. That's the powered device. And again, that could be like a surveillance camera. That could be an access point. That could be an IP phone. It could be, there's lots of things that are starting to become power over Ethernet powered. And here's one of those times, by the way, here's one of those times where we can say, here's what's new, but it's not what you're not going to be tested on the new stuff. So let me tell you what you need to know for the exam, and then I'll tell you what's new. Obviously, power over Ethernet has been it's been evolving for many years. When I first worked with it, it was back in the year, I think it might have been back in the year 2000, 2001, before the IEEE standard ever came out. Cisco had their own version of power over Ethernet. They called it Cisco Inline Power, and it provided a whopping 7.7 watts of power, and it was primarily to power their Ethernet or their IP phones. Then, about a year or so later, the IEEE came out with their first standard. It was 802.3 AF. Now, is this a coincidence or what? The industry standard says we'll give you 15.4 watts of power. That seems like a oddly specific number, but it's exactly double what Cisco had come out with. It's almost like the industry is going to say, we'll show you, Cisco. We'll do twice what you're doing. I don't know if that was a discussion or not. It just seems suspicious to me that it's exactly double. But I want you to know that number. And then later on came out 802.3 AT, and it can provide 30 watts of power. These are the ones I want you to know for the exam. But by the way, 802.3 AF, you might hear it referred to as a Type 1 device. 802.3 AT, that's a Type 2 device. There are 802.3B, as in boy, 802.3 BT devices out there now, not for the exam, but there are Type 3 802.1 BT devices and Type 4 802.3 BT devices. The 802. The Type 3 device can provide, I think it's 60 watts of power. The Type 4 device can provide 100 watts of power. We can start to run like household appliances almost on these on power over Ethernet. It's pretty amazing. I just bought an Ethernet switch the other day for my new home because I've got so many power over Ethernet devices. I've got like 9 access points and about 10 cameras, and my wireless controllers, power over Ethernet. Just to make sure I didn't run out, I got a 750 watt switch to make sure I could accommodate everything. And by the way, you might wonder, when we attach a power device, a PD, to a switch like this, how does it know how much power that device wants? Well, the way it traditionally works is the switch would send out this little pulse. You might call it an FLP, a fast link pulse. And it sends out this pulse that sort of loops through the switch and comes right back. And it sees how much current is drawn by that pulse being sent. That tells us, if you do the formula of voltage equals current times resistance, resistance equals voltage divided by current. The reason I held my hand up there, I've got this visual. My degree's in electrical engineering, so that was a little memory aid that I was accessing right there. But basically, it sees how much resistance is in the device, and that tells it how much power it wants. And it provides it the right amount of power. Now, what I was telling you earlier was that LLDP and some newer implementations of power over Ethernet, if both devices support it, you can actually do LLDP you can use it as a negotiation mechanism to determine how much power you need. Now let's hop out to the live interface and let's just see how power over Ethernet is configured. we'll start out here. We'll just stay on switch 2, and I'll do a show power inline command. And this tells me that my IP phones, they are currently drawing power. They're considered to be class 2 devices. Class 2 devices. And they're currently only drawing 6.4 watts of power, but they can draw as much as 15.4 watts of power. So that would be the maximum. That tells me that we're running 802.3 AF if that's their maximum. Let's say that I wanted to adjust this. Let's say I didn't want to overtax my power supply. I've got a lot of devices I'm plugging in. Maybe I wanted to trim back the maximum on a port. Here's how I could do that. Let's go into Fast Ethernet C0/4. We'll use that one again. And I'll say power inline. And to turn it on, you can say odd. No, notice there's not an on option. We don't want to inadvertently provide power to an unsuspecting laptop. So it's never just on. We can automatically discover if a power device is attached. But yeah, we'll just say it's auto, and we can specify the maximum watts in milliwatts for this interface. So I know that my phones right now, which I think it's pretty amazing, these are 8845 phones, and that they've got color displays, they've got video cameras, but they only take up 6.4 watts of power. That just blows me away. But if I want to just limit this to 6.4 watts of power, I'll say it's 6,400 milliwatts. And if I do a show power inline again, it's going to show me that, yep, for this port, the maximum wattage that I can give out is 6.4 watts of power. Any questions before we take our break? Like I said, I got a revelation going to Avengers Endgame. We need a break when a class goes on for this duration. So we're going to take a 10-minute break here in a moment. But I want to see if anybody has any questions first. Let's see. Vladimir says, how can you modify LLDP messages? For instance, can I specify call manager IP address in LLDP? It really depends on the device itself as to what information it's going to provide. I have not personally seen a way to, other than limiting the information, we can say you can say that, the TLV select and don't send this piece of information. I haven't seen a way of creating custom messages, which sounds like what you're asking. I've not seen how to do that. All right, I'm not seeing any other questions in the queue right now. So what I'm going to do is I'm going to put on, it's going to be like a little 10-minute video. It'll have some music with it, and it will do a countdown timer for 10 minutes. So you can just look at the screen and know how much time it is before we come back. When we come back, we're going to carry on, and our next topic is going to be unidirectional link detection. I'll see you back for that discussion in 10 minutes. Enjoy the break, everyone. All right, welcome back from the break, everyone. Let me get our slides displayed again. I did see one more question come in during the break. Somebody was saying, Danny's saying, Kevin, no, you're not a big fan of brain dumps. That's putting it lightly. I'm very much against brain dumps. But the question was, okay, but don't they help you understand a lot of the minutia, a lot of the theory going on? How do you know what to study for? Well, we're going to talk about this in a lot more detail a week from tomorrow when I'm going through an exam prep session with you all. But the quick answer, the abbreviated answer is print out the blueprint that I gave you earlier, evaluate how you feel about each of those topics right now. Can you talk about each of those topics for several minutes? And if so, put a check by it. You feel good about that topic. If not, you want to spend some more time on that topic. And after you go through a study plan, which we'll talk about next week in session number 4, if you want to go through that checklist again and see if you still have any weak areas and you really, really want to focus in on those, flashcards can be super helpful. But you should be able to say, all right, bring up a topic and I'll talk to you about it. So somebody should be able to say GLBP, and you go into the details about GLBP, not just what it does, but talk about how weighting can be used to adjust how the load balancing algorithm works and how many members there can be in a group. I mean, just all the details like that. Make sure you feel good about it. And that's still not a guarantee you're going to pass on your first attempt. The first attempt might be what I call an investigative attempt, where you're just seeing what's on the exam and maybe you need to go learn that. I fail a good percentage of my exams. That's not very motivational, but that's just the way the game works. You've got to be okay with not necessarily passing all your exams on the first attempt. Sometimes I'm going in there and I know enough to pass. Sometimes I go in there and they ask some off the wall question that I didn't see coming. And okay, study that for next time. But a lot more on exam preparation coming up in our final session. Let's see. Oh, yeah, that was our break time. Let's get into our next big topic right now. It's unidirectional link detection. Now, this is becoming less and less important, honestly, thanks to bidirectional fiber. Like, I think I might have mentioned to you that I got gig fiber installed in my home that we're building, and I was asking the technician as he was installing it. I was expecting like 2 strands, like here's your traditional fiber optic cable, and you've got these 2 strands. You've got one for transmit and you've got one for receive. And he was just connecting, looked like just a single cable, and it wasn't one of these little. Here's an MTRJ connector, which actually has both fiber strands in one little connector. No, it was a single strand. And the way that works is they use different wavelengths to send download versus upload. So they can send downstream and upstream on the same cable just by using different wavelengths, different frequencies of light. But all that to say, this is not very helpful in those situations. But if you do have the traditional 1 strand for transmission, 1 strand for reception, what unidirectional link detection can do is help detect if one strand gets damaged, but the other strand is not damaged. Sometimes it's, I remember when I used to work at the university, we would call it backhoe fade. It was amazing when there was construction going on at the university campus. It's like there was a magnet that just drew the backhoe to the fiber optic cable. And I cannot tell you the number of times that cable was severed. So that it happens a lot. And what unidirectional link detection will do is, by default, every 15 seconds, it will send a pulse on the transmit lead. It will send a pulse over to the other side. And it expects to get an acknowledgement coming back to it. Because, it's if it's able to transmit, how in the world is it supposed to know that the reception is not working? Well, if it's not heard from its neighbor, it starts to get really suspicious. So what it's going to do is, if it detects that, I'm transmitting, but I'm not getting anything back, it concludes that one direction is damaged. So it will go into one of 2 modes: normal mode or aggressive mode. Normal mode really doesn't do that much. Normal mode says, that's odd. I'm going to put this port into, for your notes, I'm going to put this port into an undetermined state. Does that mean we're blocking the port? Not necessarily. We'll talk about spanning tree protocol later on in the course. It just means that if spanning tree says it should be forwarding, we're still going to forward it. We'll generate a syslog message. We'll just like pop up a message saying, warning, we've got this UDLD warning, but we're still trying to use the port. In my mind, that kind of defeats the whole purpose of UDLD. In my mind, if UDLD is failing, if it thinks that there's a link broken somewhere, I don't want to use that port. So I much prefer aggressive mode. Aggressive mode says I sent out my little pulse using a layer 2 MAC address. There's the MAC address on screen, and I didn't get anything coming back. All right, I need to test this link, and I need to test it hard. And here's what it does. Every second for 8 seconds, it sends out another UDLD message. Bam, 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 bam. Eight in a row for 1 per second. And if it still doesn't get any response after sending 8 of those in aggressive mode, it's going to say, whoa, something's up. We're going to put this port into an error disable state. And in an error disable state, we're not going to be using that port to forward traffic. And I want to show you how to set this up. So let me turn my video off again. And let's go back out to our live interface. And first, we'll just stay on switch 2. I think that's where we are. Yeah. First, let's enable UDLD globally. I'm going to say configure terminal UDLD. Oh, yeah. I needed to show you the options. Aggressive, that's what I recommend. Enable simply means, I wish they would say normal because they're talking about the normal mode there. And we'll modify one of these message parameters in a moment. But let's say we want to do aggressive. I'll say UDLD aggressive. And now let's set one of the message timers. In other words, how often am I going to be sending out these UDLD messages when everything is up and happy? By default, it's 15 seconds. If I want to adjust that for some reason, I can adjust it to 10 seconds. That's how we would do that. And now here's what's interesting. Look at this. I want to say show UDLD. And on this switch, I've got 2 fiber ports, but the rest are copper ports, like RJ45 connectors. But I've got 2 fiber ports. If I do a show UDLD, I want you to notice something. On my copper port, like Fast Ethernet 0/1, UDLD is disabled. It's disabled on all of my copper ports, but let's scroll all the way down to the bottom. Pardon the scroll. Hope that's not making you dizzy. If I go down to my fiber ports, it says, oh yeah, we're enabled and we're in aggressive mode. That's something that I want you to put in your notes. If you just turn on UDLD by default, it only applies to your fiber ports. Now, that's not to say that you cannot apply it to your copper ports, but you cannot do it globally. You've got to do them like one at a time or go into interface range configuration mode. That would save time. Let me just give you an example. I'm going to say interface Fast Ethernet 0/4. Ethernet 0/4, and I'm going to say UDLD port, and notice aggressive is my only option here. So I'm going to say aggressive. Actually, I say it's my only option. If I just pressed enter right there, that will be normal mode. But I could add on aggressive, which is what I like to do. I'll say aggressive. Now, if I do a show UDLD, if I do that at 0/4, now it says we're enabled and we're in aggressive mode. So that's how you can turn it on your copper ports. And when we look at our running configuration, we see that our copper interface has this command. Let's see, maybe find it again here. Yeah, it says it's enabled and it is in aggressive mode. But let's say that on the copper port or the fiber port for that matter, something happened. We stopped getting those UDLD responses. We sent out 8 messages within 1 second apiece intervals. We didn't get a response. We're in aggressive mode. Bam, we went down. We went down because we think something is messed up. And we didn't just go down. We went into an air disabled state. How do we come out of that state? Well, we'll talk about another way of coming out of an air disabled state later on in the course. But one way is to simply do a UDLD reset command. Now, right now, I don't have any ports that have been disabled by UDLD, so there's nothing really to reset, but that would do it for us. Any questions on UDLD before we move on to our next topic? Let's see. Here's a question. What kind of SFP, that's small form factor pluggables, what that stands for, by the way, will you use for your Ethernet switch in your new home? Oh, it's mounted. I was going to bring the switch over here and show it to you. It's right behind me. I've actually got a 48 port Ethernet switch that are all gig ports, but it does have slots for 2 small form factor SFPs, and it's got slots for 2 SFP pluses, which is going to allow me to put a 10 gig. You see, as a side note, since you asked, I'm using a Cat 6A wiring in my new home that allows you to go for 100 meters at 10 gigabits per second. Cat 6 will only go 25 meters at 10 gigabits per second. But I want to go maybe, who knows, longer than that. So I had Cat 6 installed throughout the home. And I'm going to have a copper SFP plus port on my switch into which I'm plugging that Cat 6A cable. Now, right now, no, I don't have anything that speaks 10 gig, but I'm really, really, really wanting one of the new iMac Pros that has a 10 gig interface, and they're coming out with a new Mac Pro this year, so might be picking that up. We'll see. Let's see. Would a shutdown, no shutdown command take the port out of UDLD disable mode? Yes, it would. Yes, it would. Let's see. I buy your argument at the brain dump. How do you know whether the recommended answer is correct? I had to challenge a Test King sample on their website, got a courtesy thank you note, but I never got my $25 they promised for the mistakes I pointed out. Yeah, I think Test King is I think that they don't even exist anymore. Cisco aggressively goes after and prosecutes those people. That's a great point, though. Even with the brain dumps, you can't really trust it. I was talking to the head of like all Cisco certification programs at the last Cisco Live, and we were talking about cheating because I had just written a blog article on cheating on the exams and why it was just a bad idea. And I knew that they did. He was telling me that they had, I'm trying to remember the term he used. They have 2 PhDs in psychometrics working on their team, which analyzes the behavior when you're taking the exam, and they can predict with great accuracy if you cheated or not, if you'd seen that question before. And I told him my guess. I said, all right, tell me if I'm right or wrong. Or I said, here's my theory. My theory is you've got a big data collection from people that have taken your exams. And like for a particular question on a particular exam, you know that on average, it takes somebody, 45 seconds to answer that question. And it's sort of in statistics, you've got the Gaussian distribution for a normal distribution, the bell curve. And my guess is if I were writing test analysis software to see if somebody was cheating or not, I would say, all right, let's measure the average time against the student response time. And if there are 2 standard deviations outside of that range, then that's a red flag. And if they have so many questions in which they have exceeded 2 standard deviations, they've probably cheated, and they're going to have to be questioned a bit more before you give them a pass on this exam. I've given a lot of thought, and I said, I think that's what you're doing. He said, in his very charming way, he said, no, you're wrong. So I don't know exactly what they're doing, but 2 PhDs in psychometrics, yeah, I'm sure they could come out with things that I would not. Bottom line, stay away from this stuff, folks. It's just going to mess you up. I'd much rather take an exam twice than cheat with the brain dump. But down off my soapbox now. Back to UDLD. Any other questions? Let's see. What is the purpose of UDLD? I know you've got a fiber break in one direction. Does it raise an alarm? It does. It creates a syslog message. I meant for your fiber port, since you mentioned. I'm sorry. Yeah, the fiber port. It's not in my switch. Yeah, where it's the bidirectional fiber that they have coming in, that does not plug into my switch. It's AT&T. AT&T has their own fiber termination box. It comes in fiber. It's just one. It looks like an SC connector, honestly, but I'm not sure it is. I haven't checked the size, but it looks like an SC connector, and it just plugs into that box. And then that box also has an RJ45 connector that comes out at a gig speed, and that plugs into the Wi-Fi equipment. So yeah, my equipment's not terminating their fiber. They gave me they didn't give it. They rent or sold me a box that lets me do that. All right, great questions. Love it. Let's see, UDLD, we've already talked about how to set that up. The next big topic for the day, I'm just kind of looking ahead at our notes here. We've got just a couple of major topics coming up today, so we'll have plenty of time for questions. I want to make sure that we don't rush anything. But let's go back to what we were talking about earlier today about the fundamental operation of a switch. We said it's going to learn which MAC addresses live off of certain ports, and it's going to build a table. And when a frame comes in destined for a MAC address that we've learned, it's only going to go out of the port off of which that MAC address lives. Well, that's great. That's going to help performance. It's going to let us do full duplex. We don't have to do CSMACD. It's awesome. Unless we're trying to do some troubleshooting and doing some packet capture. Because if I'm using something like Wireshark, which I recommend you look into if you've never played with it, go to wireshark.org, not .com, .org, and download a free copy. It's one of the best troubleshooting tools out there, and it's free. So go get a copy of that. And when you're using Wireshark and you plug into a switch port and say, all right, I'm going to capture packets going to this server. No, you're not by default, because the switch is not going to send you any of those frames, because it's sending it out the port that the server is connected to. It knows where the server is connected based on the MAC address. And you're not it. It's not going to send them to you unless you use, now some vendors will call this port mirroring, but Cisco calls it SPAN, for switched port analyzer. We can go in and we can say, I want to designate a port on my switch as a SPAN port. And I want to create a SPAN session where I'm going to be making a copy of traffic coming into or going out of a port. I'm going to make a copy of those packets, and I'm going to send those copies out this other port that we specify. Guess what's connected to that port? Yeah, it's our sniffer. It's like Wireshark running on a laptop. We're going to be able to capture those packets because we're instructing the switch to send us those copies. So in this example, the server is going to the client. The sniffer is plugged into Fast Ethernet 1/0/12. Let's say that I want to see all traffic on Fast Ethernet 1/0/1. Well, I could go in, and I'll do this live, and I'll show you the commands in a moment. I could say, I want to make a copy of all those packets seen on that port. Now, I could say just coming into that port, just going out of that port, or both. Or another option you might want to put in your notes is I could say make a copy of all packets appearing in a VLAN. I could get an entire VLAN's worth of packets copied and sent to me if I wanted to do that. Now, here's the challenge. Here's the danger with this. The danger with this is, let's say that we've got good intentions. We're doing some troubleshooting. Somebody's got slow performance. Something's up. We plug in to a switch. We say, let me configure this as a switch port. We type in the commands that I'll show you in a moment. We do our packet capture. We fix it. And we say, yeah, it was a duplex mismatch. We're all good now. And you go away. You left that port configured as a span port. Later on, some unsuspecting network admin comes along and says, I need to install this new PC. Here's a vacant port, plug, and it goes into that port. And suddenly, and the user's probably not going to know it, but come on, it's not a good security practice. That unsuspecting user is receiving copies of all this extra traffic. At the least, it's getting a processor hit from having to analyze all those packets that are coming in. So what do we do about that? Well, number one, don't do that. Try to be really good about not leaving a span port configured as a span port if there's a danger that somebody's going to come along and plug in a PC. I'll tell you at Disney, here's kind of the general rule that we made up. We said that we're going to designate for all thousands of switches. We're going to designate for every switch that we install, the very last port on the switch is going to be the span port for that switch. Even if we need it right now or not, we promise each other we're not going to plug in like a PC into that very last switch port, because we're reserving that for troubleshooting. We're reserving that to run span on when somebody comes along and is troubleshooting something. So we never plugged in a PC into the very last port on a switch. And if it was a modular switch, we've got different Ethernet blades, it will be the bottom blade, very last port in that blade. That helped get around that problem I was telling you about. Now, there's a variant of this. Now, what I just explained with span, that was technically local span. In other words, I plugged my PC with the Wireshark software on it. I plugged that into the same switch that I was of the device that I was monitoring. So I was simply making copies on one port and sending those copies out the other port on the same switch. But sometimes the port I want to monitor is not on my switch. It might not even be in my building. What do I do in a case like that? We can use something called remote span. You see, when we do the configuration, I think this will make a lot more sense when we look at the configuration. But as we do the configuration, we're going to say, what's the source of the packets and what's the destination? What am I copying and where am I sending those copies, essentially? Well, with local span, I say, what am I copying? That's where my client's connected. And where do I send those copies? And I say, it's going to be this other port where my PC's plugged in. We're running Wireshark. But with remote span, we have a trunk set up between these switches. Now, I know you learned about trunking back in your CCNA route switch studies. We're going to revisit trunking in this course big time. But just realize that we have an Ethernet trunk, an 802.1q trunk between these switches. And for remote span, let's say that my sniffer is on switch 2, SW2, but I'm wanting to make a copy of traffic happening over on SW1 to that client. Well, what I'm going to have to do is configure span on both of those switches. But here's what's different. I still have to say, here's the source, here's the destination. How can I say here's the destination when the destination lives on another switch? Here's the secret. Follow me on this. I create a VLAN whose sole purpose in life is to carry span information, to carry copies. And I've got a trunk set up that allows that VLAN to go across the trunk. So what I do is say, make a copy of traffic seen on Fast Ethernet 1/0/1. That's the source. And then I say for the destination is going to be this VLAN that I've created just for carrying the span traffic. And that VLAN is going to go across the trunk to switch SW2. On switch SW2, I have a span session configured. Guess who the source is? That's right. It's my special RSpan VLAN. And the destination is the port to which my sniffer's connected. That's what I want to show you how to set up. By the way, this is what you need to know for the exam. You have to know both span and RSpan, mainly RSpan. But just to keep you up with what's out there today, Cisco also has a feature called eSpan. Not sure what the eSpan is. It extended span, something like that. Anyway, it's eSpan. That will allow you to monitor traffic not just across a trunk. It will allow you to monitor traffic on another subnet. You're actually crossing a router. That's just an FYI. That's not something you need to know for the exam. But what do you say we go out and we set up both local span and then we'll set up remote span? So let's go back out to our live topology. Turn my camera off while we're doing this. And let's go to switch SW1. I'll switch SW1. Let's create a monitoring session. Now, by the way, I could have more than one span session configured. We could have a couple or three people with their network analyzers connected in, and they're monitoring different things. That's fine, but they're just each using a different span session. So I have to create different session numbers that are locally significant. But we're just going to have one. I'll say monitor session. I'll give it a locally significant number of 1. And I'll say, what's the source? What do I want to make a copy of? The source is traffic seen on interface of Fast Ethernet 1/0/2. Now, if I just press enter right now, it's going to say, okay, we'll make copies going out of that port and coming into that port. Or if I give some context sensitive help, I could say just do traffic being received or just being transmitted on that port, but the default is both. And that's what I want to do. So I'll just press enter there. Oh, by the way, that was for an interface. Remember that I could say that my source was an entire VLAN. That's cool. But here, I'll just use a single interface. Now let's specify the destination. I'll say monitor session 1. That's got to match. Same session. The destination, where am I sending these copies? I'm sending the copies to Fast Ethernet 1/0/20. And we're done. That's how simple it is to set up local span. And I can verify it. Here's a great verification command. Show monitor. And it says, yeah, we're doing this with a local session. In other words, the source and the destination are both on the same switch. We're going to make copies of traffic seen on Fast Ethernet 1/0/2 in both directions. And we're going to send it to Fast Ethernet 1/0/20. Awesome. That's how simple it is to set it up. Now, let's think about RSpan. With RSpan, again, we're going to go across a trunk and we're going to monitor a port that lives on a switch at the far end of a trunk. Let's say that sitting here on R1, SW1, this is the switch connected to the device that we want to monitor. Let's say that the device we want to monitor is connected to Fast Ethernet 1/0/0. So I'm going to say, I'll say monitor session. I'll say 2. I don't want to overlap my locally significant session numbers. Monitor session 2. Actually, before I do that, remember I said that the destination is going to be a VLAN itself. I'm saying make a copy of a frame seen on this port and send those copies to this VLAN, which then goes over a trunk. Well, let's create the VLAN. I'm going to say VLAN 50. I'll give it a name of RSpan for remote span. And I need to say that it's actually a remote span VLAN. That's what it does. So I'll say remote -span. Now I can say, what's my source? What's my destination? I'll say monitor session 2. The source that I'm monitoring is interface Fast Ethernet 1/0/1. I didn't specify a direction, which implies give me both transmitted and received traffic. Then I'll say monitor session 2 destination. And that destination is remote VLAN 50, which is then going to flow over the trunk that we have going down to switch SW2. In fact, I'll prove it. I'll say show interface trunk. We'll see this command again when we talk about trunking later on. I think we'll talk about that tomorrow, in fact. But you'll see that, yeah, that interface is indeed currently trunking. So let's go to switch SW2, and let's do a show VLAN brief. And I predict that I will have VLAN 50 created for me. See that RSpan VLAN? I don't have to create it here because I configured something called VTP, the VLAN trunking protocol. We'll talk about that. I think that comes up tomorrow as well. But that allows me to create a VLAN on one switch and it's learned on another switch. And that's a requirement. We have to have VTP set up in order for this to work. So I've already set that up on these switches. All right, let's specify the source and the destination. I don't need to create my VLAN because VTP took care of that, but I do need to set up my session. I'll say monitor session. And just to prove the numbers don't have to match on each end, I'm just going to pick a different number. I'll say monitor session 3, and the source is the remote VLAN 50 VLAN. So I'm getting my copies from there, and I want to send those copies out to the port attached to my end station. So I'll say monitor session 3 destination, and that's going to be, let's say it's interface Ethernet 0/7. We'll pretend. And that's it. That's how we configure remote span. Let's do a show monitor. And we can see this time that this is a not local, it's a remote destination session. The source VLAN, RSpan VLAN is 50. The destination is interface fast Ethernet 0/7. And if we gave the same command over on SW1, I'll say, pardon me, I'll say show VLAN, not VLAN. I want to do a show monitor session. I forget what number, was it 2? I think it was 2. Yeah, it's a remote source session. The source is this port, and I'm sending it out of VLAN 50. That's a look at span and RSpan. Any questions about anything? Now would be a perfect time to ask. Any questions about anything? We've just really got one major topic coming up today, and then we can spend the rest of the time taking your questions. But I'll give you just a few moments to chat in any questions. Hitten says, also, do the monitor session numbers match on both switches? Oh, you asked that before. I actually, we were thinking about the same thing at the same time. Yeah, I demonstrated that, and no, they did not have to match. On your source on switch 1, did you have to have interface fast Ethernet 1/0/1 to be an access port for VLAN 50? Oh, no, I did not. It did not need to belong to VLAN 50. In fact, we're not going to have any ports that really belong to VLAN 50 because we are setting VLAN 50 aside. We're designating it as only being a VLAN used for remote span traffic. Okay, any other questions? Any other questions? Give us just a few more seconds. All right, let's get into our last topic of the day. And feel free to be thinking of some questions you're going to ask at the end of today's sessions. End of today's session, because yeah, it looks like the questions have actually been a little bit light. You've asked great questions, but I just expected a higher volume. I guess maybe because when I taught the masterclass earlier in the month, we had a lot more people. CCNA route switch obviously draws a lot more students than a higher level training like this one. So we had a lot more questions. Good to know for next time. The first enunciation is correct. Hitten says, okay, awesome. Thank you for that. Always feel bad if I mispronounce somebody's name. The next and the final topic we'll get in today is called Stackwise. You see, if I've got a bunch of standalone switches and I need to configure everything on all these different switches. Like set up VLANs, I have VTP to help me with that, but I've just got to bounce back and forth between all my different switches to set things up here, 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 and here. And that's one of the great things about modular switches. Like I used to work a lot with the Cisco Catalyst 6500 series. I call it the box that rocks. It was my favorite. In fact, it still may be my favorite piece of Cisco gear ever. I love that device. But the one I worked on had like 9 slots in it. And yeah, I could manage like a bunch of 48 port modules just from one command line interface. Because if you were in module 2 and you were like the 3rd port, you were a fast Ethernet port, you would be like interface fast Ethernet 2/0/3 or whatever number I said. Because as part of the port identifier, it would identify the module or the slot in that modular chassis. And that's great. But if I've got a bunch of standalone switches, traditionally, I got to go configure things on this switch and then this one and then this one and then this one. StackWise helps us with that. It allows us to take a bunch of standalone switches and logically group them together, and we can administer them as if they were one big chassis with different modules. The way that happens is, and I'm showing you kind of a front view and a back view here on screen. The way that happens is we have these interconnect cables, these StackWise cables, and there are ports on the back of some of our switches dedicated just for this purpose. And it's a way for us to connect at very high speeds, one switch to another. By very high speeds, it varies on your switch model, but like typical is 480 gigabits per second. So really, really fast. But we're going to be able to interconnect all of our switches. Oh, and notice if you look really careful at how everything is wired up, it kind of makes a ring, doesn't it? We go from switch 1 to 2 and 2 to 3, 3 to 4 and 4 to 5, and then 5 loops back up to number 1. This means that we could lose any of those connectors, any of those cables, and it still works. We've still got a connection from any switch to any other switch, even if we lose a connector or if we lose a single interface, it's still going to work. And with traditional StackWise, we can have as many as 9 switches in a stack, as many as 9 switches in a stack. And we're going to be able to go in and say like gigabit 5/0/2, where 5 is the switch number in that stack. Now, if we're going to have a stack, now a traditional modular switch would have a supervisor engine that was in control of all the different modules. Well, there's something similar to that here. There's, if you want to put this term in your notes, one of the switches in the stack is going to be called, it's a really intimidating name, it's going to be called the Stack Master. The Stack Master is basically the supervisor engine of this stack. It's responsible for coordinating everything between all of our different switch modules. And we can influence who becomes the Stack Master because it's based on, by default, it's based on which switch has the highest priority. Now, I think by default, every switch has a StackWise priority of 1, but we can go, I think we can go up to 10. It's been a while since I set it up, but I think we can go to 10, and we could influence maybe a higher powered switch to be a Stack Master. If you don't set the priority yourself, it can automatically elect a Stack Master. It can, first of all, it looks to see if one of your switches has a bunch of non-default interface configuration commands. If you do, they think, all right, they're really doing some heavy configuration on that switch. That must be pretty significant. We'll make it the Stack Master. But if it really doesn't find that among anybody at all, it looks at the Cisco IOS feature set on the switches. Like we might have there's the basic feature set that will be at the low end. And then we might have I don't remember what they're called, like the advanced enterprise feature set. We would go with the higher feature set to elect the Stack Master. And I said that this varies, the way it works is going to vary a little bit from one switch model to another switch model. Let's talk about a few options here. StackWise and StackWise Plus, we might see that on the 3750, like I have like I have here. And you might wonder what the plus is in StackWise Plus. Well, if we've got that stack of 9 switches and we come in on one switch port, the way it could work is we need to go ask the stack master how to forward this, or it needs to go, at least the frame needs to go out on the back plane, the virtual back plane, so that all the switches can see it and see if it's for them or not. Well, StackWise Plus is intelligent enough to know that if the MAC address we're going lives on the same switch, let's not bother the back plane. Let's not send it out to the back plane and let the stack master see it. I mean, the destination's clearly on our switch. We'll just send it right out of our switch without bothering anybody else. That's what StackWise Plus does for us. Now, for the StackWise 480, this is on some of the newer switches, like a Cisco Catalyst 3850 series switch. That gives you, as the name sort of suggests, and I think I mentioned this number earlier too, 480 gigabits per second. Wow, 480 gigabits per second of backplane throughput between your different switch modules. Now, these are your higher end traditional multi-layer switches. You can do this with some of the lower end switches as well. Like earlier today, we talked about the Cisco Catalyst 2960. Yeah, instead of using traditional StackWise, we use something called Flex Stack. Same concept, but it's not really called StackWise. And one reason is you might want to put this in your notes. You cannot have 9 of these 2960 stacked up. You can have a maximum of 4. So it's not nearly as scalable as StackWise or StackWise 480 or StackWise Plus is, but it's better than not doing it, I guess, with your 2960s. So I wanted to make you aware that that was an option. And for the final demo we'll do today, let me get my camera turned off again. Let's hop back out to the live interface. And thanks to the way that StackWise automatically does its master switch election, we really don't have much to configure. But I still want to show you how we could configure who the stack master is if we wanted to. But right now, I don't have a stack. I don't have any of those interconnect cables here in the studio with me. So I'm going to go to this Catalyst 3750, that switch SW1, and I'm just going to do a show switch. I can spell, I'll do a show switch. And it says, here's the MAC address for the stack that we're going to belong to, or if we create the stack. If we're the stack master, you see right now it says our role is the master of the stack. So we're currently the master, and our priority, I guess it goes up higher than 10. The priority is 15 right now. Okay. Right now, though, we have a stack, a quote-unquote stack of just one switch. We see the MAC address that represents the stack. Now, here's a command that lets us view the status of our stack ports. Remember, on the back of the switch, we had a couple of those stack ports. I could do a show switch stack ports command, and we can see that right now, of those 2 ports I have on the back, they're both down right now. They are both down, and that's because I don't have anything plugged into them. Now, a command that gives us a ton of information about our stack configuration, it's great for troubleshooting and verification, is show. I love the show platform option. The options we can give. Show platform, stack, manager, all. Platform stack, manager, all. And this tells us that switch number 1 has the role of master. Here's the stack master address. Here's its priority, and the current state is ready. If there were more members of the stack, we could see that here. All right. Oh, yeah, I promised to show you how to set the priority. Let me show you how to do that now. What I could do is, let me break out of this. I could go into global configuration mode, and I could say switch 1 priority, and it does go to 15. Higher is better. So I could set this maybe lower. If I did not want this to be my stack master, I could say, let's set the priority to 10. And I'll not continue right now, but that's how I would be able to do it. Well, that's a look at how it's sort of it eases our administrative burden, I guess we could say. because it allows us to treat a stack of 9 with StackWise or 4 with FlexStack switches as one big chassis or one miniature size chassis anyway. All right. That's going to wrap up the main content of the day. Go ahead and start typing in your questions now, if you would, as I discuss your homework with you. Again, when you watch the getting started video about how to do your labs, you were given an option. One option is if you're already a Vyral user or you want to go buy Vyral, we've got some labs for you. And there are 2 labs based on today's content that I would like you to do. Well, one of them isn't really a lab. It's a video to show you how you get started with Vyral, how you get it installed, how you take our .vyral file and load it into your copy of Vyral. Then I want you to go through the RSpN exercise, which is accompanied with the video tutorial. If you have real gear, if you go out to eBay and you buy what I'm using for class, I'm using one 3750, that's PoE, and I'm using 2 3560s. Why not just make them all 3560s? They don't support StackWise, and I wanted to be able to show you the stack commands. But if you can live without the stack commands, you might just want to get a bunch of 3560s. That would probably do it for you. But we've got 7 labs in that 80+ page lab document for you to do. Don't feel like you have to do all these by tomorrow. I was one of the worst at this when I would go take a training class at a Cisco Learning Partner site. My goal when they gave us a lab wasn't, I'm going to learn everything I can for this. Just personal confession time. My goal was not, I'm going to learn everything I can from this lab. I'm just going to squeeze out the knowledge. My goal was, I want to finish before anybody. And I would just rush through the lab. And as a result, yeah, I impressed my classmates by, hey, look how quick he got done. But I didn't have much idea what I just did. So I want you to savor these labs, whether they're Vyral, whether they're real gear. Go through them at a pace at which you're going to really learn the content. Please, 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 because I've been so guilty of this. Don't rush through it so you can check it off. As people say today, live in the moment. I want you to live in these labs and just soak in all that's being taught in these labs. All right, let's take your questions for the day. And again, preface it with question marks. Let's see. It looks like we've got some in here already. Let's see. How to clear switch that has been taken off the stack to its initial non-stack defaults. There are stack defaults even if it's not a stack switch. For example, the 3750 that we just visited, it thinks it's a member of a stack. It thinks it's a member of a one switch stack because it's not connected to anybody else. If you were to take one out of operation, if you just do a reboot, then yeah, it's gonna think it's a stack of 1 at that point. So there's not a lot to do there. Oh, and Chris helping out Vladimir. Awesome. Thank you for that. Any other questions? Give it just a few more seconds. Well, guys, like I said, this is the debut of our switch training. I hope you've enjoyed session number 1. I'd love to hear your feedback. If you thought it was great, please let me know that. If you think that I could do something measurably different tomorrow to make it a better experience for you, please let me know that as well. But I want to make this the best switch course that I have ever taught. I've been teaching switch content for 2 decades, but this is the most comprehensive class I've ever done because we're including so many resources with it. Thank you again for signing up. I really, in fact, just before class today, it was awesome. I got an email from a student saying that they just passed their. Actually, they posted on LinkedIn, and they said that they just passed their switch exam, and they wanted to thank me for my materials. They just had my videos. They didn't have all the resources you have. So, yeah, I'm excited. I'm excited to hear the testimonials from you all after you have an opportunity to go out and take the exam. Let's see. Not to upset Cisco, but Brocade or Ruckus has no stack secure setup and no stack. In this session somehow corresponds with the official CERT guide book. No, Vladimir, I'm making no attempt to go along with the Cisco Press book. The Cisco Press book is based off of the exam blueprint, and so is this course. But the author of that book and myself, we organize content differently. It just flows differently, but we each hit all the topics in the blueprint. All right. Don't see any other questions right now. Thank you so much for joining me. Oh, by the way, just a technical note. I noticed that we had about 2 or 3 people get in here like really, really early today. I don't know if they were just getting set and then walked away and came back, but I actually update the web page you're on right now. I insert an embed code to start the stream. That means if you come in like an hour early, it's going to be later than that when I update the page with the stream code. So when the class starts, you're not going to be able to see it because you came in early. I recommend that you come in about 15 minutes early. That way the stream will be inserted. If you do come in early, just make sure and do a reload of your web page so that you can reload the page that has the stream code embedded. So just a little technical note for you there. If you must create a user on Chatroll to be able to write in the chat. Yeah, we talked about in that little email that you should have received this morning. I'll show you how to go in and create your own free Chatroll account. Chris says homework. Yeah, homework was on the previous slide. Let me go back to it. It's also going to be in the PDF that you download later today. But there's your homework. If you've got homework with whether you're a viral user, you've got homework if you're using your own gear, or if you're using both, do all of it. That would be awesome. And if you don't have any gear, that's one of the benefits of a class like this. You get to virtually look over my shoulder as I do a lot of the configuration, and it's really possible. I recommend that you get your own hands-on experience, but it's really possible to just watch me do the labs. So I would say if you don't have viral and you don't have real gear, I'd go buy one or the other. But if you don't want to do that, if funds don't allow, just watch this course again. Pause me, take notes on the commands that I'm typing in so that you'll be able to do any sort of simulation questions that might pop up on the exam. All right. That's going to wrap it up for class today. Thanks a ton for joining me, everyone. I am excited to join you again, same time tomorrow for session number 2 of our Switch Masterclass. I'll see you then, everyone.